Well, I'm now going to put this thimble on to save myself against the possible heat burn. I'm going to let a live lightning bolt, miniature lightning bolt of 300,000 volts go right through me. Well, it certainly does give you a weird feeling, but is hardly surprising after 300,000 volts. But I'm still alive and kicking and not in a death spasm either. So let's try it again. Remember, 300,000 volts. Don't try this yourself. It's extremely dangerous. Part of the secret is to reduce the current density to under 1,000th of the level of a domestic 13-amp socket. But what other factor helped Tesla get away with it? Well, he used high-frequency current, and high-frequency current has a peculiar property. It crawls over the conductor, in this case my body, instead of going through it, and therefore couldn't reach vital organs like my heart. As an argument against Edison, it was a cheat, because domestic AC most certainly is not high frequency, but Edison had cheated, and so the score was even. In an unparalleled 8 years of invention, between 1890 and 1898, Tesla left alternating current right behind. For him, it was accomplished, of no further interest. He opened a new door, labeled high frequency, and he changed the world a second, a third, and a fourth time. Look at the similarity between this giant Tesla coil and a simple spark plug. It's not coincidental, because to drive a spark plug, you need a coil, an ignition coil, and that's based on one of Tesla's patents. The coil also worked another one of his new ideas, the lighting of rooms. Here are two lighting tubes. No wires, absolutely no supply of power. Now, let's lower the room lights and run up the coil and see what happens to these tubes. Ordinary domestic AC has only 50 or 60 cycles a second. But this is high frequency, where the coil discharges 10,000 times a second. The intense, rapidly changing field around the coil excites the molecules of gas in the tube and makes them glow. Photographs were taken by this artificial daylight. One was acclaimed by palmists, then fashionable for character reading from hands. Tesla's long thumbs showed high intelligence, they said. The argument being, apparently, that apes, who are not bright, have short thumbs. Tesla never tried to develop the lighting idea commercially, although he did go as far as to illuminate his laboratory with this forerunner of today's fluorescent lighting. If only Tesla had met more people like George Westinghouse, the only businessman to put a major Tesla invention into production. Niagara was hugely successful. It sent power as far as Buffalo, 20 miles away, and started the world's first electrochemical factory complex. The factories made aluminium, fertilizers, abrasives, and explosives. Neither the factories nor the sending of power to Buffalo would have been possible with the original DC. Edison recognized defeat. Tesla had already devised his alternating current system, his high-frequency coil, and the rudimentary system of fluorescent lighting. Enough for one man's lifetime, you might think. Not so. There was much more to come. First, in 1893, that's 2 years before Marconi, Tesla demonstrated wireless. These were the circuits he showed to the National Electric Light Association in St. Louis. This is the transmitter. It's got an oscillator, earth wire, and aerial. And the signal goes from this aerial to the receiver's aerial. And that one is a mirror image of the transmitter. Aerial, earth wire, and oscillating circuit. Now, the amazing thing is that the equipment could be tuned to receive one specific frequency. Now, very new, very modern wireless sets have a little light which comes on when the set latches onto a station. Tesla worked on the same principle 90 years ago. So when I tune this set, precisely, the little light comes on. Remarkable enough for 1893. But more was to follow. His tuned circuits led Tesla to design and demonstrate a boat, a model boat, and it was still in the 1890s, which combined both radio control and robotics. The boat operated on a lake in Madison Square Gardens, and it was at least 40 years ahead of its time. It moved forward, the rudder switched right or left, the lights operated all by remote control. The audience called out for boat movements, and Tesla maneuvered the boat from a box like this. But what's much more important is because of the fine tuning, no enemy with a more powerful transmitter could ever take over the control of the boat. Developments of Tesla radio control are now used all the way from crop-spraying aircraft to guided missiles. But when he first used them, T-clippers were still the queens of the ocean, and the main means of transport was still the horse. The world might have moved ahead faster if Tesla had been more like Edison, more interested in making money. But he was living well on his profits from the Westinghouse contract, and he could afford to indulge in his fixed ideas. Tesla believed that the inventor was an explorer, not a farmer. Explorers open trails to new lands, and they don't bother themselves with the daily grind of growing crops. That was one of his obsessions. He was also mortally afraid of germs. Even at the height of his fame, he always dined alone. His only companion, a pile of clean table napkins. The number of napkins had to be divisible by 3. With one, he kept his hands free of contamination. With another, he cleaned the glassware. He had to calculate the volume of food in every dish before he ate it. He also gave up drinking alcohol, except whiskey, in an attempt to live up to the age of 120. These fixations about health influenced his work. He was the first to suggest that high-frequency current could be applied to medicine. It's used to speed the regrowth of damaged body tissue. True to form, Tesla never patented the idea. He didn't want to profit from something that was for the good of humanity. And before Röntgen fully announced his discovery of X-rays in 1895, Tesla was able to produce pictures like this. Using one of his high-frequency lamps, he claimed to take X-ray photographs from a distance of no less than 40 feet. Tesla might have shown pictures like this before Röntgen, but disaster struck first. Fire destroyed his laboratory, with all his equipment, all his notes, covering years of effort. It was a turning point. From now on, his fortunes changed. The rest of his life was devoted to trying to transmit power and messages without wires. In 1899, he moved west to Colorado Springs, on the edge of the Rockies, where the wild terrain naturally attracts thunderstorms. Tesla believed that when lightning struck, the impact created huge electrical standing waves, rather like the crests and troughs of water set up around a pebble tossed into a pond. Each day he traveled out of town in a buckboard to test his theories. Keep on prodding the Earth at its own natural frequency, and like the lake, standing waves might set up right throughout the planet, ready to be picked up anywhere. Lightning, he thought, might do this naturally. If electrical impulses could be transmitted by this method using the stratosphere as a return path, it might be possible, it might just be possible, he thought, to make power available anywhere along the globe without the use of wires. This is the exact spot near the Deaf and Blind Institute where Tesla had an enormous experimental station built. There's not a trace of it left today. It held the largest coil he'd ever built, 52 feet in diameter. It discharged an incredible 10 million volts. Tesla called it his magnifying transmitter. It advanced his ideas about wireless and made him lord of the lightning when testing his resonance theory. And somewhere deep down, it called out his showman's streak. He arranged multiple exposure photographs of himself, casually seated while lightning streamers apparently played about his ears. The so-called transmitter helped Tesla study a wide range of radio and electromagnetic effects. He wrote up every day of 6 months' work in this, the Colorado Spring Notebook. But for some unknown reason, despite the enormous amount of effort and cost, he never published his results. Alexander Marincic is professor of electrical engineering at Belgrade University. Although Tesla is a national hero in his Yugoslavian homeland, there are statues, a museum, his portrait on dinar notes. It wasn't until 1976 that the book was published with Marincic's commentary.
Many people were interested to see what Tesla was thinking about, what he was doing in his Colorado Springs laboratory, and whether it is possible or not to transmit energy without wires. Somehow, probably many people expected to learn how to transmit power without wires. And I think probably abroad the same reaction came out, but a little bit later when that book was translated in English.
Publication gave impetus to a movement, especially in America and Canada, which believes Tesla was a century ahead of his time. The cause of power transmission without wires hasn't been advanced by the notes, now held by the Tesla Museum in Belgrade. But there is plenty more honey in the pot. Robert Golka, an American engineer, noticed that the magnifying transmitter sometimes created ball lightning. Ball lightning appears as a globe about the size of a football. It floats through walls and disappears into nowhere. Curiously enough, that's exactly what you might expect from a high-frequency discharge. Tesla said his transmitter often made ball lightning, but it was small and lasted a very short time, so photographed poorly. The very tiny bright points on this 1899 photo show all the camera could record. Golka set out to recreate this little understood phenomenon. he built the world's largest Tesla coil at a disused Air Force base in Utah. In 1945, the 393rd Bomber Squadron was stationed here. It flew regular practice runs for the day it was to drop an atom bomb on Hiroshima. Enola Gay, the plane which carried the bomb, was in the hangar next to the one containing Project Tesla. Golka believes that ball lightning can help start up nuclear fusion reactions and solve the world's energy problem. Unlike present-day nuclear fission power stations, which create radioactive waste when heavy elements are split, nuclear fusion should be cheap and clean, because it works by combining readily available hydrogen isotopes. But it needs tremendously high temperatures confined in a tiny space to get it going. Golka thinks the apparent self-containment mechanism of the ball lightning football could supply both startup energy and container. Golka's coil goes one better than Tesla's. It discharges a spectacular 25 million volts. If one of the streamers makes ball lightning, all this terrific energy should be contained inside the ball. Golka inspects the discharges at close hand, wearing a protective suit. Unfortunately, it hasn't worked. Long-lasting ball lightning hasn't appeared. Golka has retreated to raise more money, and Project Tesla is in suspended animation. But Teslarians following other clues are still hard at work. Most Tesla enthusiasts concentrate on his work with wireless and his experiments at Colorado Springs. They claim that this interference with shortwave radio transmissions is caused by a Tesla magnifying transmitter. The noise is called the woodpecker because it makes a little pecking noise 10 times per second. It's been going on since 1976 and it's blotted out radio transmissions on frequencies between 6 and 20 megahertz. 10 pulses a second is extremely low frequency. The woodpecker's been traced to Latvia. There seems to be a second transmitter near Kiev and a third further to the east. It's not jamming, it's too random, so what are the Russians up to? Andrew Mikrovsky is an official working for the Canadian government in Ottawa. In his spare time, he runs a group called Planetary Association for Clean Energy, PACE for short. PACE thinks the Russians are using a Tesla transmitter to affect the way we behave.
Now, the signals, especially the one that you see on the oscilloscope, which are magnetic only, and by the way, that's the Soviet signal, that happens to be something that can work on my brain and anybody on this planet at this time, because it is the same frequency in the same frequency range, and it is also the same type of activity that goes in our brain. That is the terrible thing about the Soviet signals, the capacity to impose on the way people would, quote, think. This thinking I'm talking about is the thinking of being peaceful, the ability to be calm, the ability to rationalize, are all affected from a purely mental point of view by signals of this nature.
Is there any defense? This personal transmitter puts out 7.8 cycles a second, which Minkowski says is a natural planetary frequency the body is tuned to. It swamps the incoming signal from the woodpecker. Remove the transmitter's protective field, and the Russian signal reasserts itself.
It is being used, as far as we are aware, by the German civil service. There in Germany it's called Weiterset, and it is mainly a protective mechanism to ensure that a German civil servant, especially on external affairs duty, is able to keep his composure in negotiations, or especially with other people, other countries, to make sure that they're not influenced.
The German government denies using the Weiterset, but Minkowski is sure it works. That's one approach to the problem, but there's a more likely solution. The Russians might be trying out a form of over-the-horizon radar, which would allow them to locate incoming objects with extreme accuracy, even if they're totally out of line of sight. One analysis says every woodpecker pulse carries a sophisticated code. Each pulse lasts 3,100 microseconds. Over a sequence of 100 microsecond intervals, the signal is counted as a 0 until it reverses phase or direction. Phase reversal changes the 0 to 1. Each further reversal alters 1 to 0 and back again until all the pulse has been transmitted. The final list gives what's called a maximum length pseudo-random binary sequence, a unique code. When a signal is returned from an approaching object, it can only be used if its pattern matches precisely the pattern of the transmitted signal, a sort of key that fits into a lock. The result gives a radar system which can see 5 times further than any ordinary radar of the same power, or more likely, 5 times more accurately at the same distance. There's almost certainly no connection with Tesla and the magnifying transmitter, but ELF, extremely low frequency, will be most important for the United States submarine fleet in years to come. Could submarines be protected by a development of Tesla's wireless work? Submarines are at their most vulnerable when they approach the surface to communicate with their headquarters. To change that, the US Navy is building 2 giant wireless stations up near the Canadian border, in Wisconsin and Michigan. Each of them will radiate under 4 watts, just enough to light a doll's house, but the power behind each transmitter will be enormous. The station at Clam Lake needs 2 aerials, each 14 miles long. That's because the signals, like the woodpecker, will go out at extremely low frequency, ELF, which requires special arrangements. Because ELF is low frequency, it takes a long time to send a message, but it does penetrate the ocean to great depth. Vessels like the newly launched Ohio will be able to receive operating orders without ever rising to the perils at the surface. Most Teslarians believe that the great man described ELF transmissions in his patents, and that the US Navy went back to those patents for the concept. But what did Tesla actually say? It is necessary to employ oscillations in which the rate of radiation of energy into space in the form of Hertzian or electromagnetic waves is very small. The lowest frequency would appear to be 6 a second. All credit to Tesla for even thinking in this area, but it becomes clear from the context that he was describing the sending of electrical energy without wires through the Earth, and not the sending of radio waves through the sea. We're in at the beginning of a new scientific cult, based on what seems to be misunderstanding of Tesla's work. The problem for modern Teslarians is that Tesla himself got it wrong. His wireless experiments were based on inaccurate theory, and power transmission without wires can never be made to work efficiently. It was Tesla's search for the Holy Grail, and it failed. He never had another success. And as time went on, his behavior became more and more obsessive. By the 1920s, his only real friends were pigeons. He came here to Brown Square in New York to feed them regularly, particularly a favorite one of his, which he loved like a brother. He socialized only once each year, his birthday, when he gave a party for journalists who were looking for gee-whiz stories. Tesla gave them the lot. Weather control, death rays, interplanetary messages. At the same time, his name faded from the role of serious scientists. The sad thing is that he did still have brilliant ideas for the future, but nothing to do with electricity. In the 1920s, he designed this vertical takeoff aircraft. The pilot's seat swivels to keep him upright when the plane trims for horizontal flight. Ridiculous? Not at all. How about this experimental American aircraft, the Convair Pogo? He planned to power the plane with another of his inventions, the bladeless turbine. The idea went back nearly 50 years to his childish design of a water wheel in the stream near his home. The machine works both as a turbine or pump, using an effect called boundary layer drag. It's now being manufactured in California. The working part of the pump is the rotor, and the liquid or gas go in here. The boundary layer effect forces it to the outside of the spinning discs. The discs revolve extremely fast, and at the beginning of the century, the metal Tesla used wasn't good enough to avoid stretching under the strain. That problem has now been solved by C.R. Purcell, the reinventor and improver of Tesla's concept. His 5-horsepower machine throws 100 gallons of water a minute, but the device's real value is its amazing flexibility.
This pump has a unique capability of pumping a wide variety of materials. For instance, we pump half-inch diameter rocks up vertically 65 feet in a small amount of air. We also can pump live fish from the nets in the ocean right up to the cannery without damaging the skin of the fish at all. We pumped a Trub sludge for a brewery that was 82% solids, which I believe is a world record for this type of pumping. This idea of using boundary layer drag is Tesla's basic idea.
But Tesla is mainly remembered today for the wrong reasons, for the things he didn't do. Why have his real achievements suffered such a total eclipse? Well, at one level, he had little interest in commerce or selling his ideas. Unlike Edison, Westinghouse, or Marconi, he left no company behind him with a vested interest in promoting its founder's name. Then, he was not willing to discuss his ideas with his colleagues. Instead, he gossiped to journalists. But most of all, I think, he had no university contacts, and he never published his results. Had he done so, his work would have been used as a major reference work for students for at least 30 years, and Tesla's name would have been listed amongst the immortals. Tesla died in 1943, out of phase with his world to the last. Only 5 months after his death, the United States Supreme Court set aside some of the Marconi claims to have invented wireless. Other people, Tesla included, had done the work first. But his best memorial is not wireless, nor is it the work done in his name today. Instead, it's all around us, in the world of electricity, he left to lighten our darkness.